good to go.
Okay,
Yep.
let me share my screen, right? Oof. So you guys can see the wrong screen probably, right? Let me just 1 second. Can you see the screen now? So you can see only introduction to Amazon ECS, right? That's what you can see, correct?
No, I still cannot see the screen.
Was it?
Yep.
1 second, right?
Yeah, it's loading now.
It's loading here.
Okay.
Make it full
Yeah,
display.
I can see the screen.
Okay. So in today's session, we're going to talk about introduction to Amazon ECS. ECS is Elastic Container Service. So just want to set the agenda. So before I jump into ECS itself, I want to talk about a little bit about containers. Okay, why containers we want to use. The world was running finite before that as well, right? What is the specific problem containers solve? Then we move to the next topic, ECR, Elastic Container Registry, and then we move to ECS, and then Fargate, right? So those are four areas we're gonna touch upon at a broad level. And as part of this, right, we'll go through to reasonable amount level of detail, and probably if time permits, right, I will show you some quick demo and other things as well. How does it look like on AWS console, setting up this container, setting up the clusters rapidly using ECS itself. So hope it makes sense from agenda standpoint. That's what you guys are expecting. And please, be very open, ask questions as you as we go through. And the key intent is, right, you guys come here, you're taking a time out from your Friday evenings, which is not the best time, right? You learn out some things and clarify any questions, doubts as part of it in this session. I will try my best to answer, and if I'm not able to answer something, I will take these questions offline and come back to you in the later stage as well. Okay, so then let's make a start. So first thing first, right? you know what are containers, right? Why so many customers are talking about it on a constant basis? And just before we're just talking about is, you guys, a lot of from the UK as well, and from Europe, from Denmark, other places. And just want to know one more thing, right? How many of you are kind of part of the development life cycle, in the early days of it, or you want to get in developer journeys, essentially at the moment? So I assume, you guys, Raghu has already mentioned, right? So a bunch of you already come to technology background, essentially, yeah. Uh, so okay. Uh, so containers really are an evolution, right? In the past world, we used to have virtualization. So you have large physical servers. You cut you slice servers across. You virtualize the machine. You have virtualized machines, right? Now, and container is the next stage of it. Okay. Uh, so so contains really a kind of a evolution of virtualization technology. It's a virtualized hardware. Virtualized machines are what we use it for day-to-day basis. We have been using, the VMs we're using for years, and now, containers are being taken the main stage everywhere, right? And Amazon is, AWS provides these facilities extensively. So within a kind of virtual machine, if you see, right, we typically have an operating system, which is for every virtual machine, it has a separate operating system. But for containers, that's the big difference coming into play, right? Uh, so containers a little bit further up the stack. So instead of virtualizing the operating system and hardware, you are instead virtualizing OS level components. The operating system makes processes believe that they are running in their own environment. They cannot see the other processes running on that operating system and have access to their virtual resources, right, including the file system tree. So that makes a kind of you know good difference, that why containers are coming to the forefront at the moment, and that helps to solve a lot of problems. Okay. Uh, So, so why companies are kind of adopting to containers, right? So predominantly three big reasons in my view. First thing is you want to accelerate the software development. Second thing is, when you want to build modern applications, you need to work, with agility. You need to work with speed. You need to have the ecosystem to support those kind of things. Essentially, think about a scenario, right? Like, you're working for a kind of large enterprise, a large bank in the UK, and they're gonna have a constant need of requirements. The requirements will keep on changing on day-to-day basis. But what you need to have the ability to align to those changes as rapidly as possible, right? And to do this kind of whole thing, the complete starting from your requirement stage to moving to your build phase and then to kind of testing things, you want to make sure that you reduce the cycle, life cycle for that. And that basically means is we need to automate the operations as much as possible, and containers help to do that in an extensive manner. If you you know uh, and if you in the industry, if you go around, right, every second customer are moving their workloads to containers itself at the moment. Already they moved their kind of big, they have deployed a massive amount of container implementations. Sorry. Hi, somebody is not on mute. Can somebody actually go to mute, please? Okay. Yeah. So if you walk around, kind of, if you go to kind of, tomorrow into your jobs itself, you will find that a lot of enterprises moving their workloads to containers, right? And the fundamental reasons for that is to drive agility, to drive speed, so that they can meet the continuous business demands. So so hi, somebody is not on mute. Can you please go on mute, please?
It's done installed. It's now it's done that. It's now installed.
Raghu, you want to check who's not on mute?
I can't just speak tree because when I speak the tree, just go and then maybe sir. Hey,
Hello.
it's me tree.
Raghu, I can't see the kind of chime itself. Can you see who is talking?
It's Linda.
Can you please ping her?
Yeah, I just muted her. Yeah.
Okay, thanks, Raghu.
No problem.
Friday evenings, yeah, this can happen very much. So if you see, right, typical application environment. So in an application environment, there are a couple of components. So you will have your runtime, like, running your application either in the kind of a Java stack or a kind of a .NET stack. You will have some kind of JVM over there if you're running a Java itself. You will have your code. You will have, your code will be running on that runtime environment. You will have a couple of configurations which will be saying that I'm connecting to this backend system, we're making this service call, so that will go to your configuration part of it, and there'll be a lot of dependencies on top of it, right? I require this particular jar file, or I require this particular library, and there's no end to it, because if a typical enterprise application, if we see typically the code base grows over the year, and this ecosystem becomes a lot more complex itself. So what will you see in these kind of situations, right? Uh, how the code flows from across different environments. The typical pipeline is, so you'll have running, the developers gonna start work on their local laptops or the local desktops, wherever they want to work on. They build things and they move the code to staging QA environment, right? And then it goes for the kind of couple of testing environments typically, and then it moves to production. Okay, but if you see in this whole life cycle, one thing is your code working standalone. But typically in enterprise, that's not the way things work, right? You will making kind of lot of integration in the backend and other places. So you're making calls to different systems, and depending upon whether you're moving the code, those configuration needs to change as well. You will require specific kind of software packages to install on this environments as well. Like as a developer, you're working and I require this particular library. You're going to download it, and then you're going to say, now, move this my code across, right? You may probably miss the library you've downloaded in development machine to the next stage. So this is the kind of typical thing which happens, that when you're going for this development life cycle, a lot of developers working at the same time, and then we typically miss things, and that creates lots of problem for the deployment and other activities, right? I'm sure this must be sounding familiar to many of you. This is exactly what we're talking about, right? Some we're running different versions, 6.0, some we're running 4.0, and maybe 7.0 somewhere else, right? So how do we make sure that, the typical comment from the developer that it worked on my machine, I don't know why it's not working in production, correct? Because somebody is going to deploy in production, overnight or something, and the developer has gone somewhere. But now, how do we make it out, correct? So to make sure that we avoid this kind of challenges, we bring consistency, we make the whole package as a single unit, right? We need something essentially, right? And that's where containers comes to the rescue of it. Yeah. So what if I do my code? It's the runtime along with the code and the dependencies. I bundle all together. Okay, and then I push for it. That guy is a kind of a standalone unit which works pretty much. It's been tested, and now you can just go and run this standalone unit across your environments itself. Yeah, and this can really help to solve multitude of typical deployment pipeline issues at a massive scale, right? And that's where, and second thing is a very much self-contained thing. Like you can say, I want to do only this specific thing. This particular unit does only this particular part of it, correct? And that's where it links very well to microservices as well. Microservices, self-contained microservices. And similarly, if you put in kind of a runtime, which is a container, and that becomes a full bundle of it. So hopefully it makes sense, right? So moving to the next stage, right? Because we talked about now why do we require containers, correct? And few more points on that particular things. There were VMs in the past, okay? So what's the big difference between containers versus VMs? So one of the most important thing we need to understand, if you see this diagram over here, so containers are shown over here. So you have Linux kernel, which is separate out. But if you see in the VM basically, right? So you have Linux kernel and you have virtual, hardware over here. So containers share a common kernel. So all components are built into kernel itself. What it does is basically this makes containers to fast, and this makes containers pretty fast to start. Okay, so if you want to stop the container, start the container, it's pretty fast, right? But if you need to reboot the VM, it is good speed, but still it takes a lot of time, which is not acceptable. Okay, what you have done basically is with containers, you have done the operating system part, you separate it out. Okay, it's in a separate place, and then you're running your package on top of it. Okay, uh, with VMs, you need to run a full OS and kernel in order to use right. Each VM handles boot processes, including device initialization as well, correct? So these extra things makes VM a lot more expensive, a lot more complicated compared to containers, which are very lightweight, which shares a common Linux kernel, which shares a common kernel, and then you can make it start stop at a rapid pace. Okay, so if you see container images, right? Now we have a container, so we want to have a kind of image. Container is going to have an image at the end of day, right? Okay, so it's the kind of basic building block of a container. Okay, so each container is an image, is a composite of things. When I say, right, it has a readable, writable layer on top of it. If you see over here, right, writable layer, okay, and bunch of read-only layers after that. Okay? So if you can update these images, and then you can make the new kind of you can make changes to it, and you can make new container images, right? So assuming you have a code base, and then you make changes to code base, and you build it again, and then you build a kind of publish a new container as part of it. So is if you see Docker typically, right? So you have Docker file which we use, which is to reproducible builds at the end of it. So hopefully it makes sense, right? This part is clear. Like, why do we require containers, and how it is going to help us, and what's the container image looks like. Okay, I'm gonna move forward. But now the question is, we come right. Basically, is we have defined a single unit. Container is a single unit, right? Which we understand that, which is well defined. Uh, you know, so managing a single unit is pretty easy, correct? But if I say, to run your application, you need probably hundreds of containers. Okay, think about, say, running on Amazon.com, right, or any large website in the UK itself, say Sky News or whatever it is. Uh, eh, to run that thing, it will require hundreds of containers to run behind it, correct, to power it. So, but how do you manage that part? Okay, how make sure that the containers start at a particular point of time, they stop at a particular point in time, they have a specific kind of size they want to use it, what's the kind of port they want to listen on, correct? So, uh, so for that, we need to do more, right? Okay, so the whole management aspect needs to come into picture of it. Uh, and before I get into that, let me talk briefly about, we talk about container images. Okay, uh, we will talk briefly about uh, container registry itself. Yeah. So if we see the kind of container service landscape, uh, we have the registry, where we go and register the images. Okay. So this is kind of a, you have Docker Hub kind of thing you have used probably. So Elastic Container Registry offers similar kind of things, but in a lot different way, right? Yeah. I'm going to come to that in a minute's time. So then how do you host your containers, right? Because I got an image. So there are different options to host it. Like you can host on an EC2 or Fargate. And how do you manage it? So Elastic Container Service, right? Which is the kind of topic for today, ECS. So AWS offers the other one as well, alternate to it, which is Elastic Kubernetes Service. And then recently we have launched ECS Anywhere and EKS Anywhere, right? What really that means is, now you can have an application, your container service, which you can run on cloud, and which you can run on prem as well, and you can manage with a single control plane essentially. Make sense? So container registries. So as the definition states over here, right, a container image registry is a service that stores container images and is hosted either by third party or public private registries such as Docker Hub, QA, or Amazon ECR for that purpose. So Amazon ECR, if you see, it's a fully managed service, right? So you don't have to worry about where to host, where to deploy. So you just need to get on with your job, basically what the kind of business outcome you're trying to drive. So underlying infrastructure, you don't have to worry about it. It's fully secure. Okay, so you can share images, you can carve out things, who can have access to what kind of uh, 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 image, and who can and you can run a lot of scans and checks on that, they're fit for purpose. It is highly available. All right. So basically, uh, it is highly available, it's very scalable, fully redundant, and highly durable architecture. And you can really access this this across from everywhere basically, right? And then it offers you a simplified workflow behind it, right? That's a great part of it. Like, you want to give access to a bunch of developers behind it, they want to upload the kind of images onto Amazon ECR they're using. But if somebody just goes and deploys a ROG image over there, right? Something deploys really bad things over there. How do you manage that? So you can put up a simple workflow behind it, which can go for the necessary scans, or it can go for the necessary processes to make sure that whatever coming to the ECR is fit for purpose. There's nothing wrong behind it, right? So ECR offer you these kind of things out of the box itself. Yeah, so it's fully managed, is highly secure, highly available, and it just offers a workflow behind it, which you can use to make sure that whatever coming to the ECR itself is fit for purpose itself. Okay. So now, if we say ECR, right? When we say Amazon ECR, uh, it when you create, an Amazon ECR registry, right? It is provided by each AWS account. So basically, you can create an image repository in your registry and store images in them. ECR registry hosts your container images in a highly available, scalable architecture, right? And it further allows you that it gives you, if you've seen the picture, right, it gives you APIs, CLI, or console to access it. Yeah. So if you want to create a new image, or you want to monitor it, or you want to delete an image, or you want to do access control of the image itself, so you can do all these kind of different operations using using either the AWS APIs or using AWS CLI or console, right? So there are multiple different options to do huge number of different operations using Amazon ECR, right? With multiple options. Uh, Other thing which is important, that by default, your account has read and write access to the repositories in your default registry, because as you're going to get an account, you will have a default registry, and your account has read and write access to the repository is for that, right? But to to but for IAM, users require permissions to make calls to ECR APIs and to push and pull images from your repositories. So basically, if you want to push or pull an image from your repository, right, you need to run these APIs. And to run those APIs, you need to give IAM access for it, correct? Because that IAM access will allow those kind of things. So when you're going to try out, probably hands-on, so you should be able to see those kind of things. Just keep this in mind. Next thing is, you can use different kind of clients as part of it. You can use Docker CLI, to 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 run this, to do your operations, or you can use some of the preferred client, right, to push and pull images from your repository. So basically, if you want to, you have an ECR registry and you want to pull an image, you can use Docker CLI for that purpose if you're using in the past, or you can use some other preferred client, right, which you're comfortable with, to push and pull images. Okay. So now, we were talking about the security side of things, right? I got a team A and team B, and we want to make sure that, every team got a specific access, specific controls, and what they can do as part of it. And all of this just you can control using ECR repository itself. So like you have, running a kind of one web application, and second one is running a different kind of backend, backend APIs. So there can be two different teams entirely, right? So you can give very granular level access controls to for those images itself to run. Okay, and those access controls can be managed using AWS IAM itself at nutshell. Yeah. Okay. uh, Moving forward, uh, the other interesting part, right, we're talking about is on container images you can define lifecycle policies, right? So what you can do, you can define, lifecycle policies basically is specific actions you can take as part of it. So for example, you can have an app image for an app which is you given a different version number 1. You can have an image app, which you given version number 3, and there's a kind of app you don't have no tag or something over there. And then you can define a policy that if there's no tag, then you can take specific actions as part of it. Correct. Uh, so you can define this kind of automation to make sure that you keep your repository nice and clean, right? So if I go to the next slide, if you see over here, uh, this is a kind of rule with priority 1 been defined. So expire image older than 14 days, and the tag status is untagged, and then the action is type is expire. So basically an untagged image will be expired after 14 days, it's as part of it. Okay. So I'm taking a little pause, right? So I hope everything is clear coming through, and let me know if any questions, something, or I will move forward. Okay. So next thing, right, is now we talked about why containers. We talked about ECR. Okay. Now moves to next stage of it, Elastic Container Service from AWS. So if you see, Elastic Container Service is a uh, fully managed container orchestration platform, right? It it operationalizes your container workloads at a very high scale without without having you to install any software. Okay, it's a multi-tenant service, and you can spin large number of clusters, services, and tasks underneath it. Uh, so it's been widely used service in the AWS stack, and people make huge benefits out of it. So if it at a broad level, right? If we split ECS, so the fundamental thing we talked about is the purpose for ECS is we want to do scheduling and we want to do orchestration. Okay, and the two key components underneath are cluster manager and placement engine. So what does cluster manager means as part of it? Right? So cluster manager manages the health of the instances within your cluster. So you set up an auto scaling group and register your instance within your cluster. EC is then aware of your capacity and your desire for your containers. Uh, so if so cluster manager knows that, right? I need to running 2 containers over there, and then he will kind of spin up 2 containers as per your needs. But now the next question comes is, I'm running these containers, where shall I place them, right? And that's the work placement engine gonna do. Okay, placement engine on the other hand basically enables much advanced techniques. Okay, for how you want to place your tasks onto the EC2 instances. For example, if you have certain tasks that you want to land on certain instance types, or if you desire super efficient bin packaging, right, for better economics, and the placement engine will enable you that part. Okay, so just a kind of funny image, right? I'm sure you all recognize this. This is kind of our old childhood game, Tetris. So now what you're doing in Tetris, right? You're always trying to find out what's the best way to place the block at the right place, right? So that it is the best fit, for the needs. Uh, and and that's what placement engine is very similar to that, right? Where to place, how to place in the most efficient manner. Okay, so now if you uh, let's go a bit more deep into now ECS, right? What are the different components of ECS, uh, and let's see what does ECS really construct of. Yeah, so we need to, there are certain terms, and I think it will be very good to be aware of those terms itself. Okay, because that can be confusing if you do that. So first thing is, let's start with cluster itself. Okay, so what is a cluster, right? So cluster is a logical grouping of tasks or services. Yeah, your tasks or services run on infrastructure that is registered to a cluster. I'm going to come to tasks and services in a minute's time. Okay, which I'm going to provide you all the details about it. Uh, so think about it. Sorry. Yeah, the infrastructure capacity can be provided by AWS Fargate, right? So how you can provide your infrastructure as part of it is you can use EC2 instances, or you can use Ask Fargate, which is serverless, to provide the infrastructure capacity. Okay, uh, and and ho- and cluster gonna form that the group of those instance tasks or services, the logical construct of it gonna make a cluster itself at the end of it. Correct. So within the cluster, you can have container instances. So container instances is 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 basically is an Amazon EC2 instance that is running the Amazon ECS container agent, right? Okay. Uh, so when you run tasks with Amazon ECS using EC2 launch type or an auto scaling group capacitor, your tasks are placed to your active container instance itself. So let's explore this bit further, right? So we talked about cluster. Okay, so cluster is the place where the task or service is going to run. But now let's define task itself. So we were talking about containers, right? So if you see over here, I got two containers, and those two containers are being called as a task itself. And task has a definition, which is defined in a JSON format. And what task definition contains basically is it contains that how much CPU you require to run this task, how much memory you require, what's the container image, logging, all kind of different things, right? But now let's be more little bit zoom into it, right? That why do I need to call multiple containers to a task itself? So you can think about a scenario. Say you're running a website. Okay, so website has your web servers and your app servers, correct? So where your app tier, uh, which is running all the logic part of it, and your web servers running all your static content, images, GIF files, all kind of CSS coming from there. But you know very clearly that as the traffic gonna grow, your web tier and app tier gonna grow almost at the same time, right? So what you can do in that case is you can make the whole thing as a single task. Okay, so you can use the task definition, instance a kind of a instantiation of a kind of task using the task definition will give you a task, right? And you can state multiple copies of it. But now if you think about that is on the backend side, you have a database or some other backend system that is not kind of gonna scale up as per the front end needs itself, right? It's gonna scale up at a different speed. So then adding that to kind of task definition is gonna be a bad idea, right? But if I make the kind of things which are gonna scale up at a similar time and combine them as single unit, that makes a task for me. Okay, so that's why we have one or more containers, right? A group is called a task over here. So essentially, one can be my web server and second can be my app tier. I can package them together and that becomes a task. Now the next point comes is basically if I want to maintain the service, okay, I want to maintain a desired number of running tasks. Essentially, yeah. If something goes down, I want to bring something back over there. Like service basically means what, right? Is it's a kind of a I have a predictable service running for X amount of time. Like for a longer running task, we will have in a service itself. And as part of that, you have multiple different things you can play, which is maintain the desired number of running tasks. You can have running replacing unhealthy tasks, like some task is not going well, uh, probably underlying the container is not behaving well. Then how do you kind of replace those things? And then you may want to spread the data to multiple different containers itself, so you have a kind of a ELB sitting on top of it, right? Load balancer. So ELB integration, right? So that thing makes a service. Okay, so we talked about three things, right? So we got the basic container, group of containers, instantiation with a specific definition is a task. Okay, and then group of tasks can make a service itself at the end of it. Yeah. And clusters on top of it is a group of tasks or services. I hope this part is pretty clear, right? Because this is a kind of important concept in ECS overall, which you guys need to be aware of. Okay, so if we just step forward over here, this is a task definition over here. You can see in this task definition, we're providing the information like how much memory we require, 128 meg or something, and what different ports is going to run as well. And then what's the kind of image name, and what's the logging, or what's the kind of execution role as part of it. So all kind of different details we're providing, right? And we're providing something just very interesting called Fargate as well, right? So we're going to talk that in a couple of slides as well. Uh, so I believe you are good at the moment. Any questions? Okay, I'm going to move forward. Now deploying on ECS, right? Task versus we already talked about. So you can have on-demand workloads, you have long-running apps. So the question comes, right? We talked about tasks, we talked about services. When, at what time shall I choose what basically? Shall I choose tasks? Shall I choose services? Which one shall I use as part of it? Okay. A very simple difference basically I will call out, right, is for on-demand workloads, the ECS task scheduler is the best option, right? So you want to, it's pretty good for workloads that needs to run once at a recurring intervals. I want to do a very specific task. I done that. I've completed it. I will switch it off, and then the job is done. Okay. So basically, things like batch or short-lived operations, they are using you. Typically, you go for on-demand workload itself, which is moving towards task itself, and then you can invoke this thing using run task API, or you can have a start task, the custom API as well over there. The other part, which is the long-running APIs apps. So you need to have a kind of, for that purpose, is service scheduler. So it provides different kind of things. It provides health management, ability to scale up or down. Like, there's a lot of load coming at the moment, so it needs to scale up. If the load of kind of, the load is down, it needs to scale down. The service will manage that, and its availability zone aware as well. And then it is essentially at the end of it, right? It's a group of containers you are running to manage a service. Okay, so I hope this is very clear, right? That when we should run tasks and when we should kind of services over here. The next thing is, you know these services, ECS is a fairly important service. And if you see some of the kind of AWS leading services like Amazon SageMaker, which is the fundamental unit for machine learning, or Lex or Poly or AWS Batch, for running these services, it's they're running on ECS itself, right? ECS forms the building blocks for various services, for these services at Amazon. There'll be more. This is few examples over here, and it is built. This the whole premise is built for security, reliability, and to work at scale at the end of it. Yeah. Uh, and then moving just to the next stage of it. Correct. I'm going to move to Fargate. Uh, so over here, if you see, we need to do a lot of management at times still, right? We have removed so many things, but still there's a lot of work needs to be done to manage the infrastructure, to do the configurations, all kind of different things, right? And that's where Fargate comes into picture. To overcome this challenge, basically, right? We need to Fargate, which is serverless. And you guys understand serverless, I hope, right? Serverless basically is, you don't need to worry about the underlying infrastructure, so that will be completely AWS managed, uh, you know, and you just get on with the kind of the driving the business outcomes, what you need to do, essentially, right? That's the place you should put your focus on. And it you know and we're talking about serverless, right? I'm sure you heard about Lambda in the past as well, which is a completely serverless service from AWS. But AWS Fargate provides you the serverless capability to run your containers. Uh, so I was saying, right, so you need to kind of manage, this slide talks about similar kind of things, is you need to manage fair number of things with ECS, which is your EC2 instances. You need to do your OS level patching, your runtime things. But with Fargate, it will take care of all those kind of things at the end of it. Uh, so you're patching, upgrading OS agents, etc. Scaling the instance fleet for optimal utilization. You don't have to worry about it, right? Because you need to say when you want to spin up new containers, right? Or the new task itself. So that kind of thing, you just leave it to Fargate, and they will make sure that it is going to scale up at the optimal level, because you don't want to be scaling up your infrastructure when running 50 or 60%. You want to that to come to the kind of absolutely right place when you should think about scaling it up, right? And Fargate will manage that automatically. Uh, Yeah, that's what kind of the previous diagram where we're showing basically is the underlying part, which is you need to manage, and over here, that part will be managed by Fargate itself, essentially. So that the second layer is completely changed as part of this, if you see in this slide. Again, this is managed by AWS, so you don't need to provision any EC2 instance, scale or manage. You can is pretty elastic, so it can scale up and down seamlessly, and you're gonna pay only what you use. And it's very well integrated with the AWS ecosystem, like your VPC networking or your Elastic load balancing or your IAM permissions or CloudWatch or whatnot, right? Is fully integrated over there. Just a recap about Fargate is it was launched in November 2017. Okay, and the primary goal, for its launch was to make sure that customers don't have to spend their valuable time on doing things which are not important for them. Right, you offload those activities to the cloud, but you focus on essentially to do the kind of core things which is you are supposed to do. Okay, uh, and it's been some pretty extensive workloads are running on Fargate on constant basis as well. Uh, so mm, so you know AWS ECS plus Fargate offers you a fully managed container environment. So basically, what you need to do is bring your existing code, and it is production ready. Basically, you're gonna get the clusters with production ready. It's a complete ISO, PCI, HIPAA, SOC compliant, multitude of those security certifications, and then it offers you powerful integrations, right, with the native AWS services like some networking, security, CI/CD, monitoring, and whatnot. So let me do one thing, right? Let me show you a bit of screen about it. How does it look like? Uh, so if you see over here, so you guys can see the screen, correct? You can see the browser. Okay. Let me see. Yeah. So if you see over here, right, we talked about these concepts already. Like you want to set up your cluster, and the cluster you have task definition in the services, and then you have container definition as part of it. Correct. And you can pretty much define it. You can pick up the predefined definitions over here. You can do custom configurations as part of it. Let me just 1 second, right? Let me go to ECS. Yeah. So I already set up a cluster over here, production cluster. So it is running with 2 services and 4 tasks over here. Correct. And if I go to production, if you see there are 2 services running over here, and there's a task definition available for it. Correct. So the task definition 1, task definition 2 for it. And this is service as service level you're running, right? But now if I go to this service, essentially if the next tab you can see there are tasks available for it. Correct. I can go to the tasks over here, and then it shows me multitude of different tasks which are running currently at the back of it. Okay. And then if I for this task, if I see there are 2 kind of different task definitions, the website service and product service. If I go to website service, and we can see this, the whole details as part of it, right? There's a kind of fair amount of details as part of available, and that's what Fargate will kind of automate it to a great extent. Okay, uh, and sorry, and this is a product service we're talking about. This is a task definition for it, and then you can do kind of multitude of different configuration over here, like task definition name, what are the different network mode type, and the compatibilities, right, as part of it, because this is showing compatibility as EC2. So because this is using EC2 instances, I'm not using Fargate at the moment for the demo purpose, but if you want to use Fargate, right, it will show Fargate over here. Similarly, what are the different kind of the maximum allocation of a container memory reservation, how much memory has been allocated, how it's been utilized, all kind of different things. Yeah. And uh, yeah, and if I just go back to get started over here, right, it's pretty quick. Basically you go to get start tab over there, you want to pip your sample app. Okay, for your setup perspective. I pick sample app over here. You go click next. And now it's saying is the container definition is ready because that's predefined. And then the task definition is available. And then we can just go to the kind of, over here, we're not adding application load balancer, right? That's showing container definition. If I just say to application load balancer over here, okay, then it's asking me different port as part of it, correct? And if I go to next over here, it's using a service over here, right? Yeah, and this kind of setup, and then you can just go and create your uh, cluster as part of it, correct? Sorry, sample app service as part of it pretty quickly. So I'm going to take a pause over here. We're on the last 10 minutes at the moment. Yep, happy to open it for the questions. Any question do you have? Do you guys, find it useful? And hopefully it makes sense. Hello, any questions or we are good? No, sure, Wendy. I think this these things take a little bit of time, and the best thing I can suggest is, um, always to try out things, right? Uh, uh, I'm sure you guys can have a developer account on AWS. Just go there, play around a little bit with it, and that makes things a lot more comfortable, essentially. Uh, and and there are multitude of workshops available. And just want to mention one thing is, I'm not sure you guys are aware of it. AWS is in a massive journey to train millions of people on AWS cloud, and they made a lot of training programs free as well. And I think you should look into AWS.training site, and I'm sure there'll be some kind of programs which are previously which were chargeable are free as well now, right? Yeah, let me see if I can get a link now, and I can share the link over here. Yeah, try this link out, right? I'm sure you guys will have access. You probably need to create an account or something, but there are multitude of resources available over here, and try some of the workshops for sure. Correct. That's going to be extremely helpful. And there's a lot of kind of YouTube video series available, which can take you a little bit time, and go through those videos from AWS itself. And then you can start setting up these containers, start building some simple web applications, set up a simple microservice as well, right? And try to scale up and down things, and that will be quite useful. Yeah. But I just want to make sure that a base level, right? Because the things we're talking about today is about cluster, about tasks, uh, container, cluster, task, service, right? So those are kind of things pretty clear. How we can use ECS, and ECR as part of it, right? Which are kind of founding blocks for it, essentially. Okay, if there are no more questions, then we're happy to close the call. I can give you a couple of minutes back on Friday evening. Yeah, no, thanks a lot. Not to worry, Mandy. And anytime guys, anybody require help or something, please do shout. I'm sure there can be a lot of people will be happy to help you guys out. Thanks, Isvana. Mm,
Thanks, Amar. That was a great session.
okay. No, thanks, Raghu.
All right, guys.
Okay then.
If you guys don't have any other questions, then we will be closing this session, and the recording of this session is going to be available after this class. I'm going to be uploading it in the webinar module of your learning management system.
Guys, good luck with AWS with the cloud, right? I think it's the right place to do. I'm sure you guys have a bit of fun to start with, and I'm sure you'll enjoy it definitely, right? Okay. Happy learning.
All right. Thanks, everyone. Thanks, Amar.
Thanks, guys. Bye-bye.
Bye.